Hello everyone, welcome to the channel. Here we have question 15 of chapter 4, chapter 5, exploring mixtures and their separations, given in page number 92. Here the question is, examine the figure 5.26, identify the separation technique marked as S. Here this figure is given on this side. Figure is 5.6. We have to identify that which separation technique is applicable. Then we have to label the apparatus A, B and C. Then third part of the question is, which of the following mixtures can be separated by the technique identified above? Use the data given in table 5.5. Mixtures, we have water acetone, B. Water salt, C. Acetone alcohol, D. Sand salt, E. Alcohol chloroform, and F. Alcohol benzene. Let us answer the first part of the question. Here, this separation technique is called distillation method. Here, we are using a distillation flask, a round bottom flask. This is a round bottom flask. The second part of the question where we have to label A, B and C. It is called distillation flask or round bottom flask, which is kept on the Bunsen burner using a tripod stand, and a laboratory stand is also there, which is holding the round bottom flask in a vertical position, and on the top of the round bottom flask a thermometer is also properly attached through a rubber cork, and here one part of it of the rubber cork, a hole is there through which a condenser is also connected. The other part of the condenser is opened in a conical flask where it will receive the vapors in the form of liquid, and this condenser is connected to the two pipes. One is water inlet, the cool water will passes through it, and one is outlet. So this B is the condenser. So B is condenser where the vapors when comes it get condensed into liquid. C is the receiver flask where here it is a conical flask. Now we have different mixtures. We have to identify that which particular method, that is your distillation method, is applicable for these mixtures or not. We have read in the theoretical aspect that distillation method is more applicable when the temperature difference is more than 25 degrees Celsius. It depends upon the boiling point of components, and the boiling point difference, if the boiling point difference is more than 25 degrees Celsius, the distillation method is applicable. Here the boiling point of some compounds are given. These are all different solvents like water 100 degrees Celsius, acetone 56 degrees Celsius, alcohol 78 degrees Celsius, chloroform 61 degrees Celsius, and benzene 80 degrees Celsius. The first one is mixtures we are having like water acetone, second is water salt, third one is acetone alcohol, fourth one is sand salt, fifth one is alcohol chloroform, and seventh one is your alcohol benzene. So which mixtures are applicable here by distillation? Here it is water acetone. We can see that water boiling point is 100 degrees Celsius and acetone boiling point is 56 degrees Celsius. The difference is quite more than 25 degrees Celsius. So the difference will be 44 degrees Celsius. So this method is applicable, that is distillation. Second mixture is alcohol and chloroform mixture. Alcohol boiling point is 78 degrees Celsius and chloroform boiling point is 61 degrees Celsius. Uh, if I find the boiling point difference, here it is 8 minus 1, 7, and 7 minus 6, 1. This particular mixture is not very properly separable by this method. We have to use a fractionating column somewhere here near to the thermometer. That fractionating column will be having the fractionating column will be having some glass beads. So in that case this particular mixture will be separable. Otherwise the main point of separation method is applicable for that two liquids that are miscible with each other, that liquid components are miscible with each other, and that boiling point difference is more than 25 degree Celsius. So let's see here what is written in explanation part. Distillation is used to separate miscible liquids, okay, with different boiling points we have seen. And here we have already talked about the boiling point difference in both the cases. And mixtures that cannot be separated by this method, here we are having water and salt mixture, that is salt is solid and water is liquid. So if I want to separate this particular thing, we have to use evaporation method. Second one is acetone and alcohol, that is boiling points are too close. Acetone boiling point is 56, alcohol boiling point is 78. So boiling point difference is too close, difference is less, so we can use fractional distillation method. Third one is sand and salt, both are in solid state, it is a solid solid mixture, so we have to use a dissolution, that is addition of water, and filtration method. So those both methods will be applicable here to separate this mixture. And the last one is alcohol and benzene. Alcohol boiling point is 78 and benzene is 80 degrees Celsius. So 2.2 degrees Celsius difference is there. So boiling point is too close to each other. So we can utilize at that case fractional distillation method, where we will be using fractionating column having glass beads in it. So it will allow when the vapors will get formed for the boiling point having low, so vapors will get formed first, and these vapors comes in contact of glass beads, it get condensed there only for some duration and again it get vaporized. So in this way, so the boiling point difference is less than the case of fractionating distillation method will be utilized. Otherwise, if the boiling point difference is more than 25 degrees Celsius, you have to utilize distillation method. Hope you will understand about it.